SHAPE Australia is a national fit-out refurbishment and construction services business. My role at SHAPE is the Group Executive for Health, Safety, Environment and Quality. SHAPE has a fairly robust electrical safety procedure, and we developed that in the early 2000s for a number of reasons. One, obviously, is to keep people safe, but also because we are also OFSC accredited. And because of the nature of the work we perform and the environments that we perform that work in, there is often significant electrical hazards present when we take over a site. The development of our safety procedure involved not only the development of a procedure, but also development of an electrical survey document and several other resources such as toolbox talks for communicating electrical safety procedures, and also a video that was developed through the use of actors to actually walk our own people through our electrical safety procedure as part of our onboarding process. So we put a lot of time and effort into the process, and it has actually significantly reduced the number of electrical related incidents that we do have within the business. Getting to the types of environments that we often work in where the hazards are greater than others, older buildings such as hospitals, medical facilities, universities, education facilities often have the hidden risks of unsafe electrical wiring, unsafe electrical switchboards, not in the sense that they're unsafe in their current configurations, but when you start opening up buildings to do refurbishment works, you'll often find that the wiring can be unsafe. We've had many examples of cables dropping out of ceiling spaces that are not terminated, sometimes live, obviously presenting significant hazards, as well as unsafe electrical conditions around electrical switchboards and a myriad of other conditions within those buildings. So until you start peeling away the layers, you just don't know what you're going to get. Our procedure really does focus on not allowing any work to take place on any of our sites prior to our electricians actually coming and doing an electrical survey, and that is to identify electrical hazards and then manage and control those hazards. So it's quite a significant sort of process. And in the early days of implementation, we did get some resistance from our electrical contractors around the implementation of the process because it took time and it took a lot of effort to actually implement. That goes hand in hand with keeping people safe. That did materialise in actual extra costs to the business, but over a period of time, it became business as usual. And most of our electrical contractors and our trades all understand our electrical safety procedures and why we have them. In continuing on that journey, we have since reduced the number of incidents we have. We have quite a good following of trades that are more than willing to actually implement our procedures. Our subcontractor partners, our workers on site have all developed a much stronger awareness and focus around electrical safety. And some of the rules that we have, just as an example, is that only licensed electricians may cut any cable on site. No contractors other than electricians can cut, remove or handle cables on our projects. When it comes to stripping out of an older building where there's a lot of cables in place, there's a lot of risk there. We certainly don't allow any of our demolition contractors, for example, to be able to get involved in moving cables, cutting cables, even if they've been isolated or not. It's just an absolute number one no-no. With all of that, our safety culture around electrical safety is extremely strong, and I hope that the presentation that Steve's now going to give you a bit of insight into our procedures. And if you are looking for information around electrical safety, I would encourage everyone to look up the SHAPE Minimum Standards app, which is a free mobile app that you can access on your mobile phone, and we have quite a comprehensive electrical safety component within that app that would be beneficial to any business. So thanks, Steve. I'll hand over to you.
G'day everyone, I'm Stephen Meehan. I'm one of the EHSQ managers for SHAPE. I look after training, EHSQ training and risk, and I'm the lead for the production side of the business. As Phil said, most of our work is fit out in commercial buildings, ranging from very small fit outs to entire buildings, whether it be an asset reposition, base building work, integrated or multiple fit outs. We do other work, but predominantly it is in commercial buildings. And because that building is there, electricity is one of our biggest risks. So in 2008, we redeveloped our procedure. We had a very basic procedure to address cables in ceilings and, as the photo suggests there, how to deal with those bird nests. But with the changes to AS 3000, we're about pulling out old cable. We saw the need to revamp it. So there was a fair bit of consultation with the industry. We spoke to consultants, electrical contractors, electrical regulators, safety regulators and unions. And the procedure was revamped to address, incidents that are occurring with electrical and non-electrical trades, where most incidents were involving energised cables not being effectively managed and identified, and leading to workers either cutting them or thinking they were de-energised and coming into contact with the end of the cable. It was also to address, behaviours of our site management team and making sure they're aware of the risks involved, and the non-electrical workers when they're working around those cables. It was also to identify risk of existing conditions of the electrical infrastructure inside the building, to allow for better control and management of those hazards, and also to improve the planning and timing of shutdowns and commissioning. We're also looking at the verification of the work has been done and it's been done safely and correctly, giving ways to the site management team to effectively communicate with the electrician and to non-electrical trades of what's required on site. It also provided a pathway for the site management teams to communicate, plan and collect all the testing and commissioning data and allow energisation to happen as safely as possible. And it also facilitated that all lead project members were involved in the process. When people start with SHAPE, they're trained in electrical safety. I lead all that training up and we explain how they do it. So how to set the survey up, how to talk to the electricians, the things you need to discuss, the standard controls that we use, the ongoing management and energisation. There's a number of methods that we use in terms of delivering that training. So face-to-face online trainings, as Phil mentioned before, videos. All our electricians and other electrical trades are also trained in our electrical safety procedure, and that's through a toolbox talk, and we do that every time they come to site or start a new project. The key points of the survey are discussed, such as the survey, how to fill it out, the methods of isolation and protection, how cables are to be tested prior to cutting, how they're made safe and left in the field, management of switchboards and other control panels, and treatments to live parts out in the field for working around them for non-electrical trades. You'll see there's a picture there of one of the SHAPE minimum standards. So that's broken into 5 parts: electrical management, construction, wiring, lighting, temporary power. So as Phil said, you can download it, have a look. It's a great tool. So the main tool we use is the survey and protection plan. We use it to take a snapshot of what the electrical infrastructure is before we start. It's done in conjunction with the electrician, but it's filled out by the site manager. And that is a really important step because you want the site managers to be able to communicate that effectively in plain English with some technical detail and not the other way around. It just makes it so easy for them to speak to all the non-electrical trades on site about what's been done, how to behave, what to expect. So the surveys start at the switchboards and we work out from there. And those switchboards we survey is what we impact. So it could be the main switchboard, it could be house boards, as well as the tenant boards and mechanical boards, and any other control panel that may be part of the project. We work out how we're going to manage those boards through the project, how circuits are going to be isolated and locked out. And with isolation and lockout, our preference is always to de-energise downstream of those boards, so the whole board is off. The inspections for when we're doing the survey can also include cable pathways into the building, electrical rooms, substations, and other supplies that may feed into the building, like generators, UPSs, and solar arrays. From there, it's a review of the cable inside the workspace, so in ceilings, in walls, in bulkheads and risers, reviewing the 240 and 415 volt power, comms cables, security cables, mechanical control cables, dry fire, AV. Decisions are made how to manage the risk with those cables using the hierarchy of control, preferably turning everything off and locking it out wherever possible, and where not possible due to cables staying on as they need to run critical systems in the building, strategies to either relocate them after we isolate or use of RCDs, protection, signage to prevent contact. With extra low voltage cables, we also assess those and we get the electrician to advise what is the best way of doing those, and we agree upon those strategies. And a lot of the time that's tying it out of the way and signposting it. We also come up with strategies for temporary power and lighting. They're all documented when those decisions are made. The site manager and the electrician discuss and agree during the survey how to make safe to be done. This could include protection work above and below cable trays, which have live cables on the trays, and what type of materials their protections need to be made out of. So, conduits or lids, timber boxes, what isolations are required when working's occurring around those live parts, the use of signage, development of work methodologies. Our site managers will create drawings, which we use in the site induction to explain to people where those risks are. And there'll also be on-site training around the relocation of services. We're doing stair penetrations or breaking out slabs where things need to be removed out of the way. There's a whole methodology developed around that to make sure everyone understands. So it's not just the electrician, but all the other trades involved in that. The decisions are made in consultation with the electrician because they're the experts. We're the principal contractor, but they're the sparky. All those decisions are documented in a form of an action list, which becomes the agreed scope of work. And that's a really good tool because it gives something for the site manager to verify that the works have been done. And because they've written it in their words, they understand it and they can properly verify it. So once the inspections and make safes are agreed upon, the electrician will commence their work, either isolating, de-energising power wherever possible, locking out, tagging out using proper locking devices on the downstream supply, the installation of temporary power and lighting. Once the make safes are done, and that's done in line with AS 3012, they're tested, certified, those results are given to the site manager. The site manager has also tasks to complete under the make safes. So updating our project risk register, our safety plans, including relevant controls that the subcontractors need to implement, either communicating it through the site induction, through site rules, and also in their safe work method statements. Creation of site management drawings show where the hazards exist, the method of management while working around those items and areas. Organising other service trades to come in and make safe their cables. So your dry fire, your security, AV and the like, and they're also inducted into the electrical safety procedure. So anyone who installs or removes a cable will be inducted into the procedure, so everyone understands the expectations of working on our site. And then the most important part, the site manager verification that all the make safes have been done. When the survey is reviewed and signed and completed, it's signed off by the electrician, the site manager, and the project manager. The project manager sign-off is the gatekeeper for non-electrical trades to commence work on site. So if the project manager hasn't reviewed it and agreed with it and said it's okay to proceed, no one else but electrical trades can be on site. So it keeps the whole project team invested in the electrical safety of the site, because it's the only way the non-electrical trades can get onto the site is by having the PM review and sign off. So with isolation and locking out of power, it does take a lot of time in existing buildings, especially where there are areas that don't form part of the construction site, but are being supplied by the boards that we want to isolate and work on. This can take some time to get agreement from all the various tenants and stakeholders, especially where there's service and comms rooms and other mission critical services are involved. We expect that downstream suppliers are locked out, so the whole board is de-energised, either through locking or tagging out a breaker or a switch downstream, or removing fuses off a tee-off box. Isolation will also include, supplementary supplies such as generators, solar panels, and UPSs. If the team does choose to remove a fuse, there's a whole process that needs to be developed for that. And that's like verifying that all the loads are removed off the board. The electrician themselves have developed a safe working process, have trained their workers in the removal process of those fuses. The electrician doing the work has all the required PPE, such as flame-proof clothing, face shields, rubber mats, hot, voltage gloves. There's a spotter trained in low voltage rescue, an in-date rescue kit, and all these system is tested prior for the work occurring to make sure it is effective. So putting all that together does take a fair bit of time. Where a board can't be totally isolated or de-energised, we consider that board to be partially live. And that means that no work can occur in the board unless there's been an additional risk assessment done, which we call a deviation risk assessment. This assessment is compiled by the site manager in conjunction with the electrician and other relevant stakeholders, such as the consulting electrical engineer. The assessment is submitted to the general manager of the business for approval. Only that general manager can approve that work to proceed. It doesn't happen very often. I only can think of a few instances in the last 15 years the procedure's been in place that it has occurred. And we've made this process deliberately difficult to ensure all other options have been considered before going down the deviation path. In most cases, when the teams do sit down and start filling out a deviation assessment, ways are quickly identified that to do the work that are still in line with the procedure. High voltage, low voltage cables left in the field, we pull them back out of the way so that they can't be damaged, and they're terminated in junction boxes with termination connectors and labelled. The same kind of goes for ELV cables, but we use termination connectors and installation tape, which is at least double wrapped around the cable. Cables that stay energised must be protected, so either using conduits or other appropriate measures and labelled as live. And wherever possible, we fit RCDs. So these are the things and the decisions that are being made in the survey about where to put the protection, where to put the signage, what circuits need to be RCD protected. We do have special signs, as you can see here, and we also have special tape that we use to mark as visual warnings that the cables are live. Throughout the cycle, the site teams complete inspections to verify that the controls we've put in place are effective. The inspection and verification of controls for the new install are also checked for effectiveness. So we have what Phil mentioned before, the shape minimum standard. There's some pictures there of what the SMS looks like. And some of the things that the site teams are looking for the new install is things like all bare ends to new cable are taped with a contrasting colour. All temp power is labelled as per AS 3012. Cables that are left in the field that cannot be isolated are physically protected, tied out of the way, labelled. Apprentices can't cut existing cable without the cable first being tested by a licensed electrician. All live parts are covered in mechanical boards. Improvements, amendments, or additional controls are done through our safety management system. So also during the construction phase, we give a lot of time, focus, and energy into re-energising. We don't want it to happen in the last week before handover. We want it to happen a couple of weeks before to make sure everything's right. So the teams focus on those areas and making sure that those areas are finished, the areas are closed up prior to energisation. We track this through our subcontractor meetings and through our programs, ensuring all trades wherever possible complete their work in that space to be energised, namely the ceiling space, but also include walls, fixed joinery, comms rooms and the like. This is done to mitigate contact once permanent power is turned on. Prior to energisation of permanent power, the electrician is required to undertake testing of the system to prove that it's safe to turn on. So those tests are done in line with AS 3017, which is complementary to AS 3012. All the testing that the electrician does is done de-energised, and those test results have to be submitted with an energisation plan. The energisation plan you'll see on the screen there, it sets out all the tests to be done, what results are required, and that is submitted by the electrician to the site manager, who will review it, make sure all the tests have been done, and then once they've been accepted, the site manager will communicate through a site-wide toolbox talk the new hazards that are about to be introduced into the site, that being the permanent energy. With those toolbox talks, the site manager signs off the plan, allowing energisation to commence, and additional controls such as additional signage are placed where the live power will be present. Incomplete work is locked out by the electrician, and in the field, termination connectors and J boxes applied to the cables. Workers are not allowed to re-enter those re-energised areas without risk assessments being done and approved by the site manager. A lot of those risk assessments can be completed prior to energisation because there's a lot of areas that we know people will need to access, like commissioning of dampers and stuff for the HVAC system. Once energised, the electrician will then need to provide a certificate of safety for the install, which also includes RCD test results. We break up the energisation into three parts, so lighting, mechanical and general power. This is done to mitigate the risk of contact with electricity. That's why we introduce it in stages, and allows other works to continue, such as joinery, painting, defects rectification in a safe manner. The toolbox talks done prior to the energisation is done completed prior to each part, and where we reiterate the controls that we have, such as additional risk assessments, not entering those spaces, isolating and locking areas out before those spaces can be re-entered. There's agreed methodologies put in place to turn the supply, namely locking out individual circuits are turned on to verify there are no issues. So we don't turn it on all at once. It's individual circuits get turned on. And where there's energisations taking place, such in open ceilings, those areas are excluded and discussed during those toolbox talks. Once the electrician does turn on, he does have some live testing to be done, but we try and keep as many of the circuits turned off as possible. So general power, we leave all that off. That gets tested, live tested, and turned back off again, because we still have temporary power on the site. And if we remove the temporary power, all those safe behaviours that the trades and workers on site have learnt and are using, they stop using those because they're trying to plug into wall sockets and things like that. So we leave the temporary power as long as practical. So RCD protected power is there. The temp lighting is removed once permanent power is energised. And that is it. Thank you.